MOM is studying and observing the surface features, anatomy, mineralogy and the Martian atmosphere of India's first trip to the interplanetary space. In fact, a limited methane check in the Martian atmosphere gives information about the probability of past life on the planet. The vast distances of interplanetary missions are an obstacle, and the development and refinement of the technology required to these missions provides endless opportunities for spatial discovery. Upon leaving Earth, the orbiter will have to traverse the interplanetary vacuum for 300 days until Mars capturing. In addition to the deep-seated space communications and navigation guidance and contingencies, the mission would include flexibility at the end of the spacecraft. When India decided to travel to Mars, ISRO did not have time to spare since the next opportunity was only a few months away, and the next mission was in 2016, since 780 days later. Project design, development and testing of the satellite and the launch vehicle were therefore carried out quickly. Launch Vehicle PSLV-C-25 Mars Orbiter Mission spacecraft was launched with a PSLV-C-25 25th flight from the first launching pad in the Satish Dhawan Space Center, Sriharikota. The demanding PSLV-C-25 mission was strengthened with a perigee, nearest point to the world 250, and an apogea, farthest point to the Earth 23,500 km with an in-farth orbit. PSLV-C-25 Mars Orbiter Mission spacecraft. Mars Orbiter Mission is the first interplanetary planetary mission to Mars on the Earth and an orbiter built in the elliptical orbit to orbit Mars. The mission is largely logistical, despite the vital mission activities and the high demands on propulsion and other spacecraft bus systems. It was designed to perform the observation and restricted study of the Martian atmosphere with 5 payloads for the physical characteristics of Mars: Mars Color Camera (MCC), Thermal Infrared Imaging Spectrometer (TIS), Methane Sensor for Mars (MSM), Mars Exospheric Neutral Composition Analyzer (MENCA), Lyman Alpha Photometer (LAP), Ground Segment, the assistance of TTC ground stations, the communications network between ground stations and control centers, the control center, including servers, data storage and control rooms, and support of the project is supported by the Indian Space Science Data Centre (ISSDC). Both in the launch and the orbital phases of the mission, the ground component systems form an integrated system. Mars Orbiter Mission Profile 1. Geocentric phase. The satellite is fired by the booster in an elliptical car park orbit. The spacecraft is slowly maneuvering with 6 main engine burns into a hyperbolic launch trajectory, with the Earth's sphere of influence (SOI) leaving the orbital speed of the Earth plus v boost. The Earth's SOI stops at 91,847 km from the Earth's surface, which is largely the product of the troubling power on the orbiter. A major concern is how the spacecraft can be taken to Mars with the least fuel. In order to send the lowest amount of fuel possible to a spacecraft from Earth to Mars, ISRO uses a way of flying known as a Hohmann transference orbit. 2. Heliocentric phase. The spacecraft left Earth in a tangential direction in the orbit of the Earth and reached Mars in its path in a tangent way. The direction around the Sun is nearly half an ellipse. At the exact moment that Jupiter is there too, it will eventually cross the orbit of Mars. With certain permittance, this direction is possible when the relative position of the Moon, Mars and the Sun is about 44 degrees in angle. Approximately 780 days are intervalled in such an arrangement. The Earth-Mars minimal energy prospects arise in November 2013, January 2016, May 2018 and so on. 3. Martian phase. The spacecraft arrives in a hyperbolic orbit at the Mars sphere of influence, about 573,473 km from the Mars surface. When the spacecraft approaches Mars, the nearest periapsy, the plane is caught by providing a retro of the Mars Orbit Insertion (MOI) maneuver in the expected orbit around March. This figure shows the Earth-Mars trajectory. The ISRO plans to start the Mars Orbiter mission with minimum energy transfer opportunities during the November 2013 period.